Hey, Algebra 2 Trig. We're going to do the second part of 6.3, solving trig equations. And today's essential question is, how do I solve multiple angle problems? So when we're talking about multiple angles, if you look at the angle, it's no longer x. Now it's going to be, there's going to be a constant attached to it, which is 2x. Okay, it's much like the first day. We just have to add a couple steps. Okay, so the first thing I'm going to do is divide by 2. I will have sine squared of 2x equals 1/2. And at this point, remember, when I'm squaring something, I'm actually squaring the entire sine of 2x. And I wanted to show you that because now I'm going to square root both sides. And when I square root both sides, remember, you have to add a plus or minus. So if I square root both sides, it will be sine 2x equals, remember, plus or minus square root of 1/2. And then if I rationalize that, I will end up with sine of 2x equals plus or minus radical 2/2. Okay? All right, so at this point, I have to ask myself, where is sine plus or minus radical 2/2? Okay? So I'm going to write, if I look at my unit circle, sine is positive radical 2/2 and negative radical 2/2 at 4 places. And the 4 places are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And if I show you on the unit circle, just very quickly, I'll draw a unit circle. Pi over 4 is here. 3 pi over 4 is here. 5 pi over 4 is here. And 7 pi over 4 is here. And what I'm going to do is I'm going to try to write the equation with the 2n pi or the pi n. I'm going to write a general equation that will try to cover all of this. So I'm probably going to write 1 for pi over 4. And if you notice, if I add pi, I'll end up here. And then I add pi again, I'll end up here. And I'll add pi. So I'll have one equation for these two. Then I'll write an equation for this one for 3 pi over 4. And if I add pi, I'll end up at 7 pi over 4. If I add pi, I'll end up back here. So if I keep adding pi, I'll end up here. Okay? All right, so it's at 4 different places. So let's start. So 2x is going to equal, remember, I'm going to write an equation. So my first equation is going to be pi over 4 plus n pi. And the reason why I did pi and not 2 pi is because I want to end up at the second spot, 5 pi over 4. If I add pi again, I'll be under here. And then my other equation is going to be 2x equals 3 pi over 4 plus n pi. And then if I do n pi, it will cover the 3 pi over 4 and the 7 pi over 4. Okay? All right, from there, I need to solve for x, so I'm going to divide by 2 on. And I'm going to divide by 2 here. Remember, dividing by 2 is multiplying by 1/2, so I have x equals pi over 8 plus pi over 2n. And then here I have x equals 3 pi over 8 plus pi over 2n. Okay, and then from there, I'm going to write all my answers. What I forgot to write is, can we add something? We're going to add, let's have the interval be between 0 and 2 pi. Okay, so I want my interval to be between 0 and 2 pi. And the reason I want to do that is now I got to find all the answers that are between 0 and 2 pi. So if I plug in 0 in here, in for n, I'll have pi over 8 plus 0. So my first answer is pi over 8. If I plug in 1, it'll be pi over 8 plus pi over 2. I get a common denominator, so I will end up with 5 pi over 8, because this will end up to be 4 pi over 8. If I plug in 3, I'll have 3 pi over 2. If I multiply that, it'll be 12 pi over 8. So 12 pi over 8 plus pi over 8 is 13 pi over 8. And again, I'm going to keep on going until until I stay between 0 and 2 pi. And actually I missed one. I forgot to plug in 2. Let's plug in 2. If I plug in 2, I'll end up with pi over 8 plus pi. So this is 8 pi over 8. So pi over 8 plus 8 pi over 8 is 9 pi over 8. And if you notice, if I plug in 5, I'll actually end up with over 2 pi, and that's not within our range. So I'm going to stop right there. And same thing here. I'm going to plug in 1, 2, 3, and 4. I mean 0, 1, 2, 3, and 4. If I plug in 0, I get 3 pi over 8. If I plug in 2, I'll end up with 7 pi over 8. If I plug in 3, I'll end up with 11 pi over 8. And if I plug in 4, I'll end up with 15 pi over 8. Okay, and those are all my answers between 0 and 2 pi. Okay, let's do a second example. And we are just going to solve secant squared x minus 2 tan x equals 4. Okay, so if you look here, I'm going to turn secant squared x probably into using one of my Pythagorean triplets. So I'm going to turn secant squared x into 1 plus tangent squared x. And the reason why I want to do that is now everything's in tangents and I can probably factor. Okay, so now I'll end up with tangent squared x minus 2 tan x, and I'm going to subtract 4 from both sides, so this will be minus 3. Okay, and then I will factor, so it looks like it will factor into tangent x minus 3 times tangent x plus 1 equals 0. Then I'm going to set each parentheses equal to 0, so tangent x minus 3 equals 0, and tangent x plus 1 equals 0. Okay, for this one, I'm going to do a different method. I'm going to use inverse method. So I'll write it right here. I'm going to use the inverse method. Okay, so I'm going to first add 3, so tangent x equals 3. And then I'm going to actually solve for x. So I'm going to arctan both sides. So x equals the arctan of 3. And same thing here. Tangent x equals negative 1. And then I'm going to arctan both sides. So x equals the arctan of negative 1. And if you look there, the reason why I arctan both sides is because now my domain is no longer wide open. I don't need to write a general formula. It's now restricted by the domain. So what is the domain of, what is the range of arctan? Well, it's between negative pi over 2 and pi over 2. So I've got to give an answer between negative pi over 2 and pi over 2. So, and actually, sorry, we don't include negative pi over 2 and pi over 2. Okay, so where is arctan negative, at what angle is tangent negative 1 between these two values? And it is at pi over negative pi over 4. Okay, and then arctan of 3, that's actually not a value that we know. We don't know 3. So what we could do is you could put it in your calculator. And if you try to put arctan of 3, see what you get. So I'm going to put 3 second arctan. Oh, and make sure you're in radians actually. So let's be in radians. So again, 3 arctan. So it's 1.249. So x equals 1.249. Okay, so those are your two answers, and again, it's restricted by the domain when you use an inverse function. Otherwise, you'd have to write a general formula. If you have any questions, go ahead and write it down, and we'll try to answer it tomorrow.